was studio. Yeah, getting excited because physics is applied in every area of our lives. The car you drive, the food you eat undergoes motion. The food the body swallow has a mass. It moves with an acceleration to gravity to the food vacuum. The step you take, you go to a specific direction, is a bit motion. The angle with which you eat, there is a projection. Are you getting it? Projectile. Are you getting it? So physics is very exciting. It has to do with virtually most of the things we do on a daily basis. Building structures, automobile, electrical, food industry, name it, whichever areas, there is an application of physics. So once again, welcome to Apos Physics Tutor. Please click on that subscription button as you are looking at it there. Click on it, like, place your comments, share with your friends, and I would really like to see you once again. Yes, you guys looking at me. I love you. You are looking kinky because you are watching this video. Stay tuned, stay connected. Thank you. Yes, last time we talked about the impulse, the momentum, and the laws of motions. We talked about the first law, the second law, the third law. Please stay tuned and get yourself acquainted with those laws as we'll be applying those laws in solving different questions. Now, we have a question right before us. A stationary ball is hit by an average force of 50 Newton. F, which is the force 50 Newton. Yes, the force is 50 Newton. For a time of 0.3 seconds, 0.03 time is equal to what? 0.03 seconds. What is the impulse? Impulse I. What is the formula for impulse I gave to you? Impulse. I said impulse. The impulse I is equal to what? Ft. Yes. I is equal to Ft. What's the unit? Newton seconds. Which is what? Newton second. So now I is equal to what? Ft. What is our F? 50. 50 times. What is our T? 0.03 seconds. 0.03 seconds. So let's multiply it now. 50 times 0.03 to give us 1.5. So it's got to 1.5. What is the unit of impulse? To give us, Newton per second. Newton seconds. So that's the answer. Very simple, easy, straightforward. Just apply the formula, you grab it. That is it. A body of mass, 3.0 kilogram. The mass is what? 3.0 kilogram. And then a velocity, V, velocity is equal to what? 10 meters per second. Calculate the momentum. What's the formula for momentum? Remember, in our previous video I said momentum is mass times velocity. If you have not watched it, please go and click. Go back to just immediate videos I shoot on momentum. You see. So m is the mass, v is the velocity. And I said the unit is what? Kilogram meter per second. So the unit is kilogram meter per second. So that's it. So because the mass is kilogram, velocity is meter per second. So let's put the value mass. So we are going to have the momentum represented by this formula rho 3.0, which is the mass. Then the velocity is what? 10 times 10. So 3 times 10 is equal to what? 30 what? Kilogram meter per second. Very simple. Very, very simple. I told you, just understand the formula and grab it. And the last but not the least now, an unbalanced force of 20 Newton. The force is given to us as what? 20 Newton. Act on a body of mass 4.0 kilogram, then the mass is what? 4.0 kilogram. What is the acceleration we're looking for? A. This applies to what? Second law of motion. Change the momentum proportional to what? The force. So remember our F is what? Mass. F is what? Mass times acceleration. You remember I did the formula. So mass is given to us, the F is given to us. So what are we looking for? We're looking for this. So let's substitute it into the formula. So we're going to have 20, which is F. Then the mass is 4 times what is A? We don't know. So that times 8. So what do? We're going to have 20 is equal to 4A. So divide both sides by 4 to get our A. We're going to have 20 divided by 4 is equal to A. 20 divided by 4, so all they give us 5. So the acceleration is what? 0.5 meter per second square. That's the answer. Very sweet calculation. Of course, you would like to see more of this calculation. Yeah, but please take note of this question. But there's a question that's ringing in my head now as I'm looking at you now. The question is ringing in my head now. So let's quickly solve that question. I want to clean the board. Let me clean the board so that please take note. You can review the video. You see this question. It's not something that is taken away. So review the video. So there's this question that's ringing in my head now. And what does the question say? The question says a mass. Let me say put it question number 3. A mass of 800 gram. Yes, of 800 gram is pushed along a tarmac with a force of 20 Newton. Full stop. If a frictional force opposes the motion, if a frictional force of 8 Newton opposes the motion, yes, what is the acceleration with which the body or the stone, this is actually stone, the stone moves. So with what acceleration the stone moves. So now let's solve this question now. This is a question that I got somewhere right ahead of us now. So now we have the mass. The mass is given to us as what? As 800 gram. So we take it to what? To kilogram. A kilogram is what? A gram is 1,000 kilogram. So it's going to be what? 800 divided by 1,000 to give us what? 0.8 kilogram. Yes. Now that's it. It's moving along the tarmac with the force. The force with which the body was moving was 20 Newton. Yeah. But there's a frictional force or opposing force that tends to oppose the motion. Let me call this FA. Let me call this FB. That's opposing the motion, which is 8 Newton. So by the end of the day, we discover that this thing is still moving. Because they say what is the acceleration, show that it's still moving, but the acceleration reduces. So we can say the effective force is equal to the moving force minus the frictional force, FB. So the effective force, let me call this my effective force now. So what's my moving force? 20 Newton minus what's my resisting force, opposing force, or frictional force? 8 Newton. So the effective force is what? Is 12 Newton. Yes. So if my effective force is 12 Newton, now I'm having a mass of M is equal to 0.8 kilogram. So the force with which that keeps the body moving is what? Is 12 Newton. So our new force is equal to what? 12 Newton. So we are looking for what? Acceleration. Get it? For the formula, force is equal to what? Mass times acceleration. You remember? Yeah, that's the formula. Please don't forget. Use anytime, anywhere, any day, and anyhow. So the force is what? 12 is equal to what? The mass is what? 0.8 times A. So what is A? So we don't know A. So we have we divide both sides by 0.8. So 12 divided by 0.8 will give us A. So let's do it. So 12 divided by 0.8 give us 15. So our acceleration is what? 15 meter per second square. Very simple, very straightforward, very cool. So that is it. More examples are coming on personal questions, standard questions, JAM, WAEC, post-UTME questions, international questions, and from all over the places that will be likely resolve. So stay tuned, stay connected, and see you in the next video. Love you. Have a wonderful day. Don't forget to subscribe. See that thing, subscribe. Subscribe. Yes. Click it now. Click it. Yes. Then that like button that looks like this. Yes. Click it now. Good. Thank you.